What are you doing? Day 9. Try to get on the leaderboard today. Yesterday's problem was pretty straightforward, but I was struggling to write those silly for loops that like transform a single string of input into a cube, basically. So I wrote some utilities for that later. All right. No, not more encode. Good God. Why did they torment? Okay. So what are we doing here? We have another opcode 9 that does what? Just relative base value of its only parameter. Okay, so in I plus equals 2, and we do m dot rel. Okay. Now what? Okay. Okay, that's great. Super, super great. We'll just make a big prog. Oh my god. How did that work? I thought I was gonna need big nums. Okay, this is... What? Alright. We got both parts, and we got rank 10 on both. Holy crap. I'm just a little befuddled. Like, I don't know. I was not expecting either of those to work. Like it said large numbers. Is this, I guess by large it means a 64-bit? I mean, is that really very tight requirement? I guess some people's implementations might be using 32-bit or something. Actually, I think my Zig implementation uses int 32s, but it seems like if I just bump that up to int 64, that'll be fine. But yeah, this was just like a straightforward cut and paste your encode machine and then add this opcode 9, which was not too difficult, and then like run it with input 1 and input 2. It says that the program might take a few seconds to complete, but it ran pretty much instantly. So I don't know what's up with that. Okay. So this is our whole solution, I guess. Alrighty. I mean, even with that result, I'm still not super enthused about doing more encode stuff. But I mean, can't really complain, can I? Where does that take us in the leaderboard? 46. That's a big jump. I think 10 minutes ago we were down at like 76 or something. I must have gotten 180 points, right? So I would have been down at, yeah, like 320 something. Yeah. That's just bizarre. That's like one of the best, I think that might be the best score I've ever gotten. I think before that the best rank I got was 11th, and that was in one of the earlier advents. And super weird that I got the same rank on both parts. Yeah, look at that. It took about 30 seconds to do part 2. It's silly. It's just like part 2 is just your input is a 2 instead of a 1. I was a little concerned when it said it was going to run slow because with Advent, usually that means like, this uh, int code style computer is going to be calculating, factorial uh, using some naive recursive loop or something like that. It's going to be executing like an n squared division algorithm or something like that. So with those, it's like you just have to disassemble the assembly and then figure out what it's doing and then like basically JIT it by hand. You have to be a human optimizing compiler. But no, this was nothing like that. It was just, I guess it ran slightly slower than with the other input, but like, not really. Let's see. I feel like these are not going to be that different. Oh, I guess I have to reset the machine. Right? Okay. Yeah, the second one runs. Oh no, it's slower. I thought I was gonna say like looked like it ran faster, but no, it's milliseconds versus microseconds. So yeah, that's what like 500 times slower, but still. I mean, that's only a problem if your program is taking like a second to execute. I don't know. Maybe if you're writing it in Ruby or something, it actually does take that long. Wow. Okay. So yeah, this solution, I mean, subtracting the encode stuff, it's like 3 lines. Oh, that's annoying. It won't let us inline that because this returns value rather than a pointer. I'm going to change that just because it doesn't really make a difference and I want to be able to call it inline. All right, well, the night is very young. My dad just texted me. He says, my dad says, you did that one fast. I'm still boycotting int code. Hope there aren't too many more. Sad face. Yeah, I don't really blame him. My dad is doing Advent in Clojure. He's a big Clojure fanboy. And I think generally Clojure is probably a really good choice for Advent because you get all those nice, functional like collection operations. You got your map filter folds. But on the other hand, maybe not so great for any. There's a lot of Advent problems that are like simulations, which really is more of like a object-oriented programming sort of thing. Definitely more suited for that. In a functional language, it's like, they obviously provide ways to like pretend that you're mutating state when you're not really. But it's just not like it's not really built into the underlying design of the language to like really make that easy. I don't know. Yeah. Here we go again, says Adam. Did Adam already finish? I mean, I would guess so. What? Come on, Adam. Don't you have the int code stuff, ready to go? Well, maybe mine was written in a way that made this modification easier. I think the tricky part would be modifying the. Yeah, I had this nice get arg helper that I was able to just hook into that. Oh yeah, if your code was structured such that you're like manually parsing the flags in every opcode, then maybe it's a pain. You have to go and like edit all of those call sites. So maybe that's part of it. I don't know. Okay, well, it's 1:15. I am thinking that we can bang out the Zig version pretty quick. Make sure I can see the chat in here. So let's copy over the day 7 solution, because it seems like that's what I modified for the Go. And now I'm really hoping that my new recording setup worked, because I hope it captured my all-time best time. Otherwise, that'd be a bummer. Okay, so here's our Zig int code machine. All right, and so for the prog, so we're gonna allocate a whole bunch more. Oh, this is interesting, actually. I think so. When we try to fill up our program, we're gonna run out of like iterator values. And right here, it's just doing or else unreachable, because I'm assuming that we won't. But I think what I can do here is when we run out of those, we can just instead have it. It's kind of silly. It's going to feed the result into the parse, so we have to give it a string instead of just a 0. But I think that will work. We want to fill up the rest with zeros, because again, in Zig, when we allocate this thing, it's going to be filled with undefined values. It won't be filled with zeros like it is in Go. So we fill that up, and then we're just gonna do initialize with the program, and then run with our input, which is 1, and then print it out. And then ditto, but for 2. So now we just need to add this other opcode here. And the other bit of state, the relative value. What is it? It's just this.rel plus equals args dot get 1. I think that's all we need, right? And then down here we'll just record that the 9 opcode is going to bump the instruction pointer by 2. Okay, so then we need a rel value. Oh, and this should actually be the same type as that, because we're going to have to add them together. Okay. Alright, so we have to modify our arg parser to be aware of this rel value. This is like, it's sort of silly that I split out the arg parser into like its own type, its own structure. Like, it probably should just be part of the machine, but it's because previously the machine was not actually its own type. I just had like a run machine function, so that's why I split it out that way. But yeah, maybe I'll go back and merge those. Doesn't really matter right now. Okay, so we're adding rel. We have to add it to the init function. We gotta put it in here. Rel equals rel. Okay. Now in the get, let's see. So over here is instead of an if, now it's going to be a switch. We're going to switch on flags. And it's going to be 1 is A. And 2 is our, that's going to be the rel thing, I think. 0 is going to be offset mode or whatever it's called. And then anything else should just never happen, so we say unreachable. Okay. So relative mode is the same as the positional mode or offset mode, I don't know. I think it's position mode. Except that we add the rel, so it's going to be what? S.rel plus A. I think that's all good. But there is one more thing that we need to fix up. And I mentioned it before. The Zig implementation is using 32-bit ints. And I'm guessing that that is not going to be enough. So, but let's just run it and see what happens. Two cannot be cast type 1. Oh man. Right. So my flags are U1s because previously they could just be a 1 or a 0. Now they could be 0, 1, 2. I think this is all we need. I think we just bump it up to a U2. Okay. It's building, it's running, and it's exploding. Integer overflow. Cool. Okay. So Zig actually caught the overflow. I think again this is like something that if you run in release mode, it probably that becomes like undefined behavior or something. But in safe mode or debug mode, that will actually turn into a runtime error. So that's cool. And completely unsurprising. Now, with any luck, all we have to do is just find and replace all of our i32s with i64s. Honestly, I don't know why they weren't I-64s in the first place. That was just silly of me. Okay, now cross your fingers with the larger ints. Hopefully we get the right output. But we don't. Okay. Well, that's a bummer. What did we do wrong? We got 203. Both times. Nothing's really jumping out at me. It is obviously wrong here. My laptop is really upset. I think it's upset because I have Firefox and VS Code open, and that's just, it's too much for a modern Intel processor to handle. What did we do wrong? I guess we just have to try running it with the test input and see what happens. The only other suspicion I have is that, I don't know, maybe the extra program space is not initialized correctly. I guess we can test that pretty easily. Let's do prog of like 15,000. And that should be 0. Yeah, that's fine. Alright, over to just input. So, I mean, it says that the boost program, if you run it in with value 1, it will output any opcodes and the associated parameter modes that seem malfunctioning. So it gave us a 203, which means relative mode input output. Okay. Oh man. Don't tell me. Oh no. Could that be why? So with this guy, I hard-coded it to always use the immediate value, because like it wouldn't make any sense otherwise, you would think. But in my Go version, I did something a little like kind of clever, and I had get arg return a pointer. And what that means is that when you are doing the input thing, you store in like the dereferenced pointer location. And yeah, that's my guess, is that this is being modified. And so in relative mode, we want to actually be storing in a different place. Okay. Well, I mean, I guess we can like special case that. Maybe I should convert the Zig version to do this pointer thing, because I am pretty happy with how that turned out in the Go version. It's just a question of how hard would that be. I'm also not totally confident in my understanding of Zig's pointer situation. Like it does have pointers, but it also has like optionals. I think in this case we don't want an optional, because an optional is not actually like representing an address. It's just like at the semantic level, it's like, maybe monad. It's like something is there or it's not. But we actually want to be storing into some address. So this would just be a standard int pointer. Maybe I will do that. I mean, why not, right? The downside is that everywhere here, it's going to be the same as the Go version, where instead of just doing get arg, you have to dereference it. So that's slightly ugly, but we can live with that. Okay. So we're going to modify our get. This is one of the things that Go is helping us out with here, is that this is something to think of when you're writing Go. But here we're just like returning the address of some local variable, some variable that is just like local to this little inline function. But of course, in like any other language, that's a huge no-no. You don't want to be returning stack addresses outside your function scope. That's going to put you in a world of hurt. So we have to just be careful here. We can return addresses to s.p, but if it's actually an immediate thing, then we're going to have to allocate new memory for it explicitly. And I'm thinking I only want to do that if I have to. So instead of declaring a up there, I'm going to inline this. Even though that's a bit uglier. Actually, do we need to allocate, or can I just do this? Because I mean, it's not like it needs to be. It's not like the immediate actually needs to be in a separate place. Like we don't really care that it's sharing some state, because we're not going to modify the immediates. So I think that's probably going to be okay. And now we run around and we modify all the args.gets so that they're dereferencing pointers. And then we take these guys and we replace them with args.get3. That's nice. Oops. And then down here in our input, we do args.get1. I think that's all of them. Expected type found star I64. Oh, let me consult the docs here. I think I know how to do this, but I might as well look it up. I think I'm not doing the dereferencing properly. It's not C style. I think when you dereference, you actually do, you do a dot star, which is kind of funky. If you're not used to it, I mean, especially if like your thing is not a structure, then you're like, why would I do dot on something that, it's like an int? But it's sort of like the way I think about it is I think of the star as being like a, regex glob, like give me everything. So to me, it's like, sort of like saying, normal struct dot syntax, but just like give me all of the fields. Just give me all of the memory, right? So if you look at it that way, it kind of makes sense. So we have to take all of these, and instead of star args.get, it's args.get dot star. I guess it's also probably good to not have the type syntax be the same as the dereference syntax. It's probably for the best. Although taking the address syntax is still different from the pointer syntax, which maybe that's not ideal. And now that I have this, I can get rid of the immediate method because I was only using that as a workaround. And there we go. Okay. Now it's working just fine. Oh, it's I'm definitely grateful that that test program told us exactly where the problem was. And I strongly suspect that this is what tripped up other people. I think that explains my, extremely good performance tonight, is that I just fortunately stumbled upon this way of writing my get arg thing to, return a pointer. And I think I'm in a definite minority there. I would guess that very few other people wrote their get arg that way. And that's what caused a lot of hair pulling tonight, is having to adapt their get arg to incorporate the relative thing, but specifically in the case of things like setting the input, where you want to be incorporating the different addressing syntax in those cases as well, and not just assuming that it's an immediate. All right, well, I think that's all we have for tonight. both implementations in 40 minutes. Zig one took me significantly longer because I didn't realize why the Go version did not take me very long until I discovered this bug in the Zig one. So definitely consider myself lucky on this one. Probably I would be very surprised if I got a better score on any of the problems remaining in the month, but you never know. For now, I'm pretty happy, so we'll leave it at that.